Hi, I want to talk about angular velocity. We are looking on a plane angle, and we have two methods how we can describe an angle. We can say here we have an angle alpha, and we imagine one rotation of this element here is 360 degrees. Okay. So one rotation is 360 degrees. It means, do I have only a quarter rotation here? Then I have a quarter of 360 degrees, so here I have 90 degrees. That's one way. That's a degree description of an angle. We can also take a radian description of an angle, radians. We sketch a unit circle with a radius 1, and we say the way which is one rotation is then 2 pi. So the circumference u is 2 pi times 1. So it's 2 pi. And an angle that rotates 360 degrees has made a way 2 pi, or an arrow that has made a rotation which in degree description means 90 degrees. That is 2 pi times 1, that's the length, divided by 4, because we have only a fourth of this circumference here. So it's p divided by 2. That means in degree description we say 90 degrees, and in radians description we say pi divided by 2. How do I calculate this if I want to come from one description to the other description? Or I suggested to make it in this way. We write down alpha in degrees divided by 360 degrees is the same as alpha as a radian divided by 2 pi. If I then start with the degree information, I can calculate the same number for radian, or the same result for radian description. So let's start. Alpha in degrees should be 45 degrees. Then I can write it down here. I can say 45 degrees in relation to 360 degrees is the same as alpha as a radian in relation to 2 pi. So that means alpha as a radian is 45 degrees times 2 pi divided by 360 degrees. So 2 times 45 is 90. 90 degrees divided by 360 degrees times pi is pi divided by 4. So pi divided by 4 is, if I take a calculator, 0.7885. That's a radian description of this angle 45 degrees. In connection with angular velocity, we have to look again on a standard circle with radius 1. That's the radius 1. And now we imagine that we have a constant velocity of an object driving along the circumference here, and we can describe a frequency. We can say in 1 second this point is rotating 2 times around. So we say frequency is 2 per second. And if I want to calculate the angular velocity, then I write it down this way. I say omega, which is angular velocity, is 2 pi, which is the circumference, times the frequency. So the angular velocity is described with the product of 2 pi multiplied with the frequency around in this circle. So that is angular velocity. Yes, we need angular velocity in connection with the calculation of the power of a motor in watt is moment multiplied with the angular velocity. So the moment the motor is delivering, multiplied with the angular velocity, delivers the power to us if we want to calculate the power of an object which is generating a moment.